And I'm going to ask everyone to register an account. So make sure you can quickly go ahead. If you haven't already, make sure you're logged in and or register an account now. This way you're just going to be able to save your progress from anything you make here. I don't want you to do all the work and then all of a sudden it disappears. So make sure to just go ahead, register an account, and get yourself set up. What we are going to be coding today is the following. And you guys will be able to follow along with me. If you go to that URL, you're going to be able to see what we're coding today. And I'm going to share my screen so that you're seeing it exactly. So this is the final project we're going to be building. I don't know if you guys have played any of these games before, but where you control a car and you have a variety of obstacles that come down the screen. And if they hit your car, you lose. If you get past an obstacle, you gain a point. And you can use this game as the foundation for anything else that you end up building for this. Again, just use this as inspiration. If you want to do something completely different for your submission, you're welcome to. We're going to go over how to build this. All right. Then let's go ahead and get coding. What we're going to be starting with, first and foremost, you can see we've broken this down into a variety of different milestones. So the very first milestone is just how do we get this car to actually appear on the screen? And really simple is the following. So we're going to learn about a command called load image. And the way it works is the following. You create a variable inside of setup. I'm going to go ahead and close this and make sure my font is really big so you guys are able to follow along. So what I'm going to call this variable F1 car image. I'm going to say that is equal to a command called load image. Inside of load image, I put the URL to any image that I want to load. So here we already have a URL that we've created, which is the following. I'll put it over here, and I'll share it in the Google Meet as well, so you guys are able to copy, paste, and follow along. This is the image, right? So I'm going to put this in the Google Meet, so you guys are able to do that. So when you put that URL into here, into F1 car image, you need to put it in these apostrophes. It's going to load that image inside this variable called F1 car. Now, we want to make sure this is a global variable, so we're able to access it in both draw and setup. So I'm going to say global F1 car image at the top of setup. And now inside of draw, what I'm going to be able to do is I can say image, and I can say, okay, what is the image I'm going to be drawing? F1 car image is the image I'm drawing. I then need to specify a X coordinate. So let's say for now, I'm going to say 300, a Y coordinate 300, and a width and a height. And then you're going to get your car appearing here. If you want to upload your own image, the way in which you can do that is you can come to something, you can literally just Google upload image. You'll come to a website called ImageDB. You'll upload the image. Let's say I have I have a weird picture over here. You can upload it there. So this is how you can upload any images that you want. Once you do that, you'll click to come to this image. You're going to need to right-click on this image and click copy image address. And then when you put that image address in here, you will be able to load that particular image. And then you can see that's the image I just uploaded. So that's how you can upload your own images for this. But for today, we want this car. Okay, so we have the car. Let's put it towards the bottom of the screen. So towards the bottom of the screen. And if anything, what we want is to limit the width and height. So right now, we're using window width and window height. I actually want to use a predefined width and height for this guy. So I'm going to make my image 300 by 600. Let's even make it a bit bigger. 300 is a bit small. Let's go 400 by 600. There we go. Okay. So I'm making my canvas size 400 by 600. This is my car. Let's put it somewhat towards the middle of the screen. So I'm going to say our X, let's keep it at 300, but let's put our Y lower down to like 100. Actually, 300 is way too much. Let's put it at like 100. Okay, there we go. So that's my car. The next thing we want to be able to do is move the car. So as you can see in milestone 2, what's happening is when I press the left arrow key, the car moves to the left. When I press the right arrow key, the car moves to the right. The way we do that is the following. And if anything, what I actually want to do is make sure you guys click save on your projects When you guys click save, you'll now auto-save your project. And I'm going to share this URL. So if you want to follow along from where I am now, you can just come to this URL and you can click the fork button and you'll be able to follow along on your own. So if you ever get lost, I'll post the link to my project at the end of each milestone. Let's keep going. So how do we get this left and right movement that is being shown in milestone 2? So the way in which we're going to do that is with a command called if, I want to make sure I'm doing it right, key is down. So inside of draw, I want to say if key is down, and now I can, the way that our keyboard work is using something called ASCII, which assigns every key on your keyboard to a numeric value. So up arrow is one numeric value, down arrow is another one. I think, for example, if I printed the ASCII value for all of this, what you can do is you can just say ASCII table. And when you get to this ASCII table, you'll be able to see all of the different keys and what their numeric values associated with them. But there's a bit of a trick, so we don't have to memorize those values. I can say if key is down, instead of putting the numeric value, I can use what is essentially a pre-stored variable, and I can call it left arrow. So left arrow is a variable that's already defined, and it's keeping track of the value of left arrow, which I think is 37 or something, but it's not too important. So now if key is down left arrow, let's make sure that this is working. I'm going to just do a print command and just say print hi mom. And now when I press left, you can see inside of my console, I got a message that says hi mom. Okay, cool. So I know when I press the left key, hi mom comes up. I can also do the same for the right key. So I can say if key is down, and I can say right arrow. I'm going to say print hi dad. Let's make sure that that's working. Yeah, so I'm pressing right, hi dad, hi mom. But now the question is, how do we change the x coordinate of our car when that's pressed? So what I'm going to do is I'm going to make a global variable called xcar. And for now, let's just put it to anything. For now, let's start at 100. With this global variable, I need to declare it inside of draw, and I'm going to say global xcar. And I'm then able to change what this is. So when I define it over here, global xcar inside of draw, when key is down and I'm pressing the left arrow, I want to decrease the position of xcar. But to illustrate this, actually, to just before I even go there, what I can change. So this is our image, F1 car image, x, y, width, height. So here's where I'm going to put my x car. And if I just made x car equal to mouse x, you'll see that I'm going to move my car with mouse x, right? So we're seeing how we're able to control a position of something with it. Note one small thing. The position of the car is in the bottom left corner. So notice the bottom left corner is almost like this little rectangle. Ruhan, I see you put up a question. You're welcome to come off mute and ask.
How you talked about this project, right? The other project that you showed on the Notion site, you showed this like start and finish project where the car like moves more realistically if you press the up, down, left, right. So how do you make that work? And like, how do you make that work as if it's an actual car instead of making it like move left and right as if it was a normal object?
So it's going to be a little bit more advanced. I'll see if towards the end of the lesson we'll have time to show that. I can stay with you also a little bit afterwards to show that one, but because this project is a little bit simpler than the other one on the Notion.
Okay, thank you so much.
No worries. Okay, so we have x car is equal to mouse x. What we want to do now, this was just to illustrate how this is working, is I just want to change x car. So I want to say x car minus equal 10 when I press left arrow. And now you'll notice if I press the left arrow, it's going to move to the left. And then if we want it to move to the right, we're going to say x car plus equals 10. Now you'll see, okay, I'm getting this controller. Depending on how much you want to change this, right? So if you want to make it very smooth, you'll put it to like 1, and then it'll be a very smooth but slow movement. If you want to make it big, you can make it x car minus equals 100, and you'll see it's like this massive movement, but this doesn't seem like it's going to be too much fun. So 10 seems like the right number. Okay, so that is movement sorted. I'm gonna again copy paste this code into this. So if you want to now, like if you got lost, come to this point, and now we're gonna move on to the next milestone. Because the next milestone is in the obstacles. How do we get these obstacles to appear and start moving down the screen like this? So in a very similar way that we did the image for the car, we're going to do the same for the obstacle. So I'm going to make a new variable called obstacle image, and I'm going to make that equal to load image. Now we've got this image before already, so I'm going to go ahead and find that URL. Yeah, so this is our guy. I'm going to show it over here, and I'm also going to put it in the Google Meet. That's the URL. Sorry, so it's a broken down F1 car. So our first obstacle is a broken down F1 car. So I'll copy paste this image, and I'm going to put that into this load image command. So obstacle image, make sure I declare it as global, obstacle image. That way, you've got to declare it as global. Otherwise, draw won't know what this is. You won't be able to access this variable. So now I'm going to draw this particular one. So image, I'm going to say obstacle image. Where, so X and Y. For now, let's just put it anywhere on the screen. So let's say we're going to put it at 150, a Y of 450, and then a width, I think 50 and 70 looks good. Yeah, okay, you can kind of see it over there. So X, Y, width, height. And there is our first obstacle. But now we want it to move down the screen. So how are we going to get it to move down the screen? Does anyone actually have a suggestion for this? I want to make it a little more interactive. If anyone wants to give a suggestion, how are we going to get this this obstacle to move down the screen? Yeah, you want to come off mute?
You just decrease the Y coordinate?
Yes, 100%. So exact same thing. So now I'm going to make a new variable in my global scope called Y obstacle. Let's say I'm going to start it at the top of my screen. So I'm going to say 600 is where I'll start. Inside of draw, I'm going to make sure I declare Y obstacle. So I'm talking about the same thing here. And now, instead of putting 450 as my Y coordinate for it, I'm going to say Y obstacle. I think it's a bit too high, so let's just bring it down a little bit so we can still see it. There you go. And now, just every frame, we just need to decrease Y obstacle. So if I say over here, Y obstacle minus equals 10, it starts moving down. And here you can see the way in which you can play around with speed. So minus equals 1, the obstacle is going to move very slowly. 10, it's going to move quickly. 100, good luck on winning this game. So we'll stick with 10 for now. But the question is, and what you're seeing from this is that it's always resetting. So it's coming down and it resets to the top. So what we want to do in order to reset it is just write a little if statement that's going to say if Y obstacle goes less than 0, so it goes off the screen, I want to reset Y obstacle. So I'm going to say Y obstacle is equal back to the top of the screen. So let's say 500. And now you see every time it goes off the screen, it'll come back up to the top. Awesome. But one thing you'll notice is that it's always in the same line. We're always putting this Y obstacle. It's always going down the exact same thing. What we want, as we can see from this game here, is that it's moving. That like all at one time it's over here, the next time it's over here, and it's moving left and right because that's what's going to make this a bit more interesting. How are we going to get the random motion in the X position so it moves left and right? What we're going to do for that is define a variable for its X and randomize it every time it goes. So similar to this Y obstacle, I'm going to define an X obstacle. And for that, let's say I'm going to say, let's just put it at 100 for now. And I'm going to say image, obstacle image, instead of 150, I'm going to say X obstacle. Make sure I declare it in my global for X obstacle. And now I want to reset X obstacle every time it goes off the screen. So that's what I'm going to be doing inside of this if statement. So inside the if statement, I'm going to say X obstacle is equal to some random number in between the range of my grid. So we know that our grid is 400 pixels wide because we did create canvas 400, 600. So I'm going to say somewhere between, let's say, 50 to 400. And now every time you notice that the obstacle is in a different place every time. And so we're getting a more thing. It's interesting how it's Okay, no, I think it's fine. I was wondering why I'm never seeing it over there, but as I speak about it, there we go. Okay, so now we have the obstacle appearing in all these different places. The next question is, okay, what about all these different obstacles, right? And over here, I'm only seeing, right now we only have one here, but here we got a bunch. So I'm only going to do it for one more, and then, because it's just repeating this process. So I don't want to bore you guys by the simple things. We've done the hard stuff, but let's just do it for one more. So what I'm going to do is I need to say X obstacle 1 and Y obstacle 1, because now we're going to create a completely new obstacle. The URL for that one is this guy over here. I'll share that inside. So it's a tire. It's a broken tire. Why is everything so? Why can't I want to crash into something fancy and new? So that's the image that we're going to be using. So I'm going to copy paste that image. And now, so we have obstacle image. I need to say obstacle image 1, and I need to rename all my global variables as well. So obstacle image 1, Y obstacle 1, X obstacle 1. Now I'm going to create my new one. So obstacle image 2. Image 2 is equal to load image. The URL in. And then we're going to make sure we define that in the global scope, obstacle image 2. And we can see we're actually getting an error because it doesn't know what obstacle image 1 obstacle image is anymore. We need to create obstacle image 1. And we don't know X obstacle or Y obstacle, so X obstacle, Y obstacle. Now we should hopefully stop getting errors. Reference before assignments on. Oh yes, so now we need to say Y obstacle, Y obstacle, Y obstacle. There, just add all the ones. Okay, fixed. See, it's a little bit tedious when you add more obstacles. There is a fancier way to do this with arrays, but for now we're going to keep it simple and just do it like this. So obstacle image 2, let's follow the same process. So another image. I'm going to put obstacle image 2 in here. I need to define it as global in here, I think. Oh, okay, it's just not coming up. I'll just copy the name of this. So inside of image, obstacle image 2, the X of it and the Y of it. So I don't think we've actually defined it yet. So I'm going to do it now. So I'm going to say X obstacle 2. Let's put that at 300, and Y obstacle 2 is equal to 450. We follow the same process. X obstacle 2, Y obstacle 2. This one has a slightly different size, so sometimes you play around with the size of the image because otherwise it doesn't look too good. I think this one is going to look best. Yeah, you can see this massive tire on the side here. 30, 30. So width 30, height 30. Yeah, there we go. Okay, we have our tire. It is all the way at the bottom. Why? Oh, because we put it at 45 there. It should be at 450. Okay, and we follow the same thing now. Now I'm going to say Y obstacle 2 minus equals 10. I don't have it in my global scope, so I just need to put it there. Cool. Now we have both of these guys going, and then we follow the same thing. So now if I say if Y obstacle 2 is less than 0, I'm going to say Y obstacle 2 is bring it back to the top, put it up to 500, and then change the X is equal to random somewhere between 50 and 400. And I think I don't have X obstacle 2 in global. Here we go. Okay, now we have these two obstacles, and they're moving around randomly on the screen. I'm pretty happy with our progress here, and I would say that is milestone 3. We have the milestone set up. The next one is just collision detection, and this is where it gets fancy. This would be the most challenging part of this project. Before I move on, again, I'm going to paste the link to this if you want to follow along to the most updated code. So that's in the chat. How do we do collision detection? So collision detection is actually a massive field in computer science, and there's a lot of different algorithms that exist on it. We're going to do a very simple one, which just has to do with the distance between objects. We're going to say if the distance between two objects is close enough that they're probably touching, then they are. So let me show you what I mean by that. I want to draw a circle around all of our shapes in order to illustrate what I'm talking about. So let's start with drawing a circle just around our car. So this is where we're drawing the car. I want to draw a circle around it. So I'm going to say circle. And circle takes 3 commands, x, y, and diameter. So our x is the same as the car, let's say x car. Our y, we can see from here, it's 100. So I'm going to say 100. And the diameter, as well, it's 100 by 100, so we can see it there. What we'll notice immediately, though, is that the circle isn't surrounding the car. That's because when I'm saying image, it's referencing the bottom left corner of the image, like right over there. But we want the circle to be in the center of this in order to help visualize this. So I need to say x car plus the width of my image over 2, which is 100 over 2, so 50, and my y of 100 plus its height, 50. And now you can see it perfectly there. I'm going to get rid of this just so we're looking at the border of it. So, oh, sorry, no stroke. I'm going to say no fill. No fill will get rid of the fill of the circle. We can't see it because it's black, so I'm going to just say, I'm going to put a stroke of green. I'm going to make my stroke weight thicker. Stroke weight, let's make it 5. Okay, cool. So now, do you see the circle that's around my car? The way the collision detection is going to work is like, hey, if something enters the circle, it's going to collide with it. So now let's do the same. I want to just draw a circle around one of the other images. So let's do it for the broken down Formula 1 car, which is obstacle image 1. So similar process. I'm going to say circle, and now I need to draw the circle around it. So x obstacle 1, y obstacle 1, and the diameter of it, let's say for now we'll put it as like 50. Again, notice it's in the bottom left corner of that obstacle. Let's stop it from moving just for a little bit, just so we're able to actually see this. There we go, okay? So that is I don't know how well you can see. I'll try to zoom in, but you can see it's over there in the bottom left corner. We want it to be in the center. So we need to offset it to the middle of our car. So x obstacle 1 plus my diameter of my size of my car over 2. So for the width of this image, it's 50. So I'm going to say 50 over 2, so that's 25. And for y, 70 over 2. So plus 70 over 2, which will be 35. And there you can see it's in the middle. I can see that it's not perfectly encapsulated. Like if I zoom in to how big the circle is, it's not quite doing it justice. It needs to be a little bit bigger. So let's make it 70. Here we go. Okay, now it's nicely inside. So now, okay, we've done a lot of setup. You're probably like, Tamir, why on earth are we drawing so many circles? Like, please, can we just get onto coding a game? The reason why we're drawing these circles is because it's going to help you visualize the algorithm that we're using to tell if these two things are colliding. Because what we want to do to tell if these two things colliding is we want to just say, hey, are these two circles intersecting with one another? Are these two circles on top of one another? If they are, then we have a collision. So let me put that more clearly. I'm going to put for my x obstacle and y obstacle, I'm going to do the following. I'm going to just put it for now. X obstacle 1, I'm going to make that equal to mouse x. And x obstacle 2, I'm going to make it equal to mouse y. Okay, now, oh, sorry, not x obstacle 2, sorry, y. I'm being silly. Y obstacle 1. I want to just control this guy. Yeah. Oh. The algorithm goes as following. This isn't connected, this isn't colliding, isn't colliding, isn't colliding, isn't colliding, collides. So if these two circles overlap in any way, that's the collision. And now you can start to see why this is complicated, because it's not really, right? These cars aren't perfect circles. They have a unique shape. Like maybe you're just missing the spoiler by just a bit. So the way this gets more advanced is that computers then learn the shapes of these objects and are then able to very accurately tell if something is colliding. But this is the simplest way to do it at first. Okay, so now how do we tell if these two circles are overlapping? The way we're going to do it is with something called a distance formula. If the distance between these two circles intersects, we're going to, that's when there is a collision. To show you what this is in code, the command goes dist. So there's a command that goes dist, and you put x1, y1, x2, y2. If the distance between 2 points is less than something, there's a collision. In our case, it's going to be The distance, I wonder if it will take me a while to draw it, so I'm not going to draw it for now. Maybe I should actually. But we're looking from the distance. I'm going to quickly open up a mirror board to actually be able to draw this. I'll be quick because we want to move on to the next part. Okay, so here we're talking about having these two circles. That's circle 1, circle 2. This, from the center of our circle, come on, I believe in you. Try this one more time. No, I'm not going to be able. I'm trying to get a nice line to go from the middle without selecting it. Maybe this will work. Kind of. So this will do. So that is our radius, right? From the center of the circle to the edge. And we want to know if this happens. So what we want to know is this line the distance? I need to find a better drawing software. If the distance between this point, let me just do it like this. If the distance between here and here, if that distance is less than something, that is when it's intersecting. And the distance we're then going to be talking about is this radius of this circle and the radius of this circle. The sum of those two radiuses, that's the distance we're ultimately looking for. And in our case, we can tell that this is the diameter of one circle, so 70. This is the diameter of the other one. So our radius, which is half of our diameter, so it's 50 for this one, and 35 for this one, so 50 plus 35, 85. If the distance between these two objects is less than 85, there is a collision. So in code, this looks like following. So I'm going to say if this, and I'm going to say x obstacle 1, y obstacle 1. And now I'm looking at the car. So we have x car. We haven't defined a variable for our y car yet. So I actually want to define a variable for our y car. And I'm going to just do it up here. I'm going to say y car. Let's just put that equal to what it is currently, which is 100. I'm going to put global y car and put that over there. Okay, that input on line 32. Yeah, I just haven't finished it. So x car, y car. So if the distance between those points is less than the sum of their two radiuses of the bounding box of this, in which case we've said that's 85, we now have a collision. But note that we don't want to just use these coordinates, because these coordinates are the bottom left corner of our respective shapes. We want to use the center of those shapes. So the same coordinates that we used for these circles. So for my car, so I'm going to say x car center, that is going to be equal to x car plus my size of my car, which we said is 100 over 2. So I'm going to say 100 over 2. And same for y. Y car center is equal to y car plus 100 over 2. Now the same for my obstacle. So x obstacle 1 is equal, or x obstacle 1 center is equal to x obstacle 1 plus whatever the size of the circle that we've said here. So plus 25 to get it in the middle of that, because our width and height isn't exactly the same. So I'm going to say plus 25, and x obstacle 2 center is equal to it's not x obstacle 2. We're looking at y obstacle 2. Y obstacle 1. Y obstacle 1 center is equal to y obstacle 1 plus 35. Just these exact same coordinates that we used to draw these circles is what we're using. So here I'm going to replace this x obstacle 1 center, y obstacle 1 center, x car center, y car center. If the dist is less than that, we want to stop the game. So we can see the way that it's happening here is that it just stops the game and it says you lose. So the way that we do that is the following. One, we're going to just make the frame rate 0. So if I say frame rate 0, it will stop. And then we're going to say text, you lose, sad face, somewhere on the screen. Text you give that command, what you're wanting to print, and then the x and the y. So our x, we're going to say 200. Our y, let's say 250. Okay, let's test it. So now what should actually happen, and I actually want to be able to visualize this. I don't know if it will work. I think it will if I put full red, because what I want is I want these circles to become red when they actually intersect. So let's see, when I bring these close enough that they're touching, we should, all of this should happen. Yes, okay, beautiful, okay? So you see, it stopped, we got this you lose coming up. And so this is how you'll be able to very easily test if your collision detection is working. And make the variables of your object that you're wanting to test equal to your mouse X, mouse Y in order to change it. I can't see this very well, so I'm gonna just make my text size very big. Let's try something like 48. And there we go. Okay, a little bit better. It's a bit too much on the left. Can I put this over to like that? Okay, nice. Okay, so now instead of I'm going to get rid of mouse X and mouse Y, I'm going to bring back the movement. So I'm going to uncomment this line. And now you can see it's working. Okay, so now it's playing as normal, and now we just need to dodge it. So it's going very quick. I want to move this or change the speed. Let's say, and what would be cool is if you make them different speeds. So I'm going to say minus equal 8, minus equal 6. Okay, let's see. Cool. Okay, now I'm able to dodge that particular obstacle. And if I hit it, you lose. Now you're going to see how you're able to keep adding onto this and how this is going to get more and more fun, because now as you add more obstacles, the more difficult it's going to be to prevent that, prevent you from hitting one of them. So a simple thing we can do just to end things off is add a score. So I literally just want to say, I'll add a score, make that equal to 0. Score is equal to 0. I want to draw the score somewhere in the top left corner. So, okay, I need to get score in my global variable. So I'm going to add it to my list of global variables. I'm going to say text. I want to draw my score. I want to draw it at, let's say, X at 50, Y 500. We don't see it right now. That's because we haven't done all of this. So actually, I'm going to do this for that. I'm going to move. I'm just moving the commands for changing this, what our text looks like. And for some reason, oh, because I'm doing it before background. Classic. Okay, I'm drawing my text before background, so I'm not actually seeing it. So I'm going to move background up here. And there we go. Now I can see my score. Nice up in there in the top left. And then you just want to increase score whenever the obstacle gets to the bottom of the page, right? Because if it gets there, it means that we didn't collide with it. So I'm going to say score plus equals 1. Score plus equals 1. And now I have a score that's going along with this. And then you can say you end, and that's your final score. Cool. These are the building blocks, right? Everything now. So again, I'm going to copy paste this code so you guys can have a look at it. But these are the building blocks that you need to make this game. The way you guys can then take this further is have a variety. Like you could do so much here. You could have a special power up that when you actually want to collide with it. And if you collide with it, you get 100 extra points. Or maybe you collide with it and it's something random happens and the speed of the game increases by 10. So there's so many things you can add on with these foundational things of how to draw images, how to make things move, how to make your player move with your keyboard, and then most importantly, this whole idea of collision detection, which has to do with finding the distance between two object centers and making sure that they are less than something in order to know if a collision has happened. I'm going to pause there and answer any questions on this one. So feel free to come off mute or ask any questions that you might. Yeah, Chris.
So the game, it doesn't exactly have to be a F1 game. It just needs to have an F1 theme, right?
Yes.
All right, thank you.
Yeah.
About like the final project, does it have to be made using either Stripe or Replit, or can we use like just VS Code and Pygame?
It needs to it needs to be publishable. So in the sense of that it can't be hosted on GitHub. I need to be able to go to a website URL to see the game and play with it without any setup. So if you use Pygame, you need to put it up to Python, to Replit, so that I'm able to just go to a particular URL and see it.
Got it.
So then would Replit be fine to use?
Yes, yeah, you can use Replit.
Okay, great. And just to check for the video, we have until next Sunday to present it.
Next
submit
Sunday,
it.
yeah.
Okay, got it. Thank you.
Any other questions? Otherwise, I'm going to help Ruhan on his question of how that motion happened for the more advanced project, which was this guy. Any other questions, though, on this project? Cool. I'm going to assume no. Ruhan, let's answer your question. So it comes down to, I'll show you which line of code. It comes down to vectors and this idea of angle, first and foremost, and this guy. So lines 80 and 81 is how this happens. To show something, so what I'm going to do is I'm going to fork this code. Let's see, I only have 10 minutes, so maybe I'll be able to explain this. Have you done trigonometry, Ruhan? At school yet?
Not at school, but I know trigonometry.
Yeah, so the core of it is trig. So I'm going to just do fancy car. I'll call this one. And the way, so let's have a look at how this is working. I think there's also, yeah, there's a bit of a rotation, yeah. So a few things that are happening on this. So if I want to get this car to move the way that, let me just make sure, am I understanding your question? It's like, how does this motion work? Like, how are we getting that to happen?
Yeah, but like also making it more realistic and making it like better.
Yeah, getting it to be more realistic, it's going to be making, like getting the math closer and closer and constraining what it is. But you'll need to understand it at first. The core thing has to do with these angles or these formulas. So if I want to change for here, so I do have an X car and a Y car. What I need to be able to define are two things. I need a speed and I need an angle. So I need car speed. Let's put that equal to like 3, and that car angle, let's say that's just equal to 90 degrees. To work out what my X coordinate is, if from these guys, what I need to then say is I need to say X car is going to be equal to this formula. So this car speed times by the cos, so that's the cosine, so this is where trigonometry comes in. I'm going to skip over how you derive this because deriving it is a bit more advanced, but then times by the cos of the car angle. And then same, y car is equal to car speed times by the sine of the car angle. And now if I need to be able to change what, I need to essentially be able to change my car speed and car angle. So instead of doing this, or if key down left arrow, so X car, instead of changing it like this, what I need to be able to say, let's say left and right changes my angle. So I'm going to say car angle minus equals. So here you want to make it small. So minus equals like, let's just say 1, right arrow, car angle plus equals 1. But now I'm not going to actually change the speed. What should just happen is that if I just change left and right, I'm going to change the angle of it. And let's see. So I need to make sure that those are just in global. So car angle. Okay. Let's see how this goes. I want to get rid of the collision detection. So I'm doing this on the fly as well. So let's just get rid of that. And now what you want to be able to have is you always want to be having the car moving according to the speed. So that should be happening. Car speed is that. Oh, because it might be. see what is happening. Should be changing it. Let's just go ahead. I just want to quickly text car. I just want to see if car angle is actually changing right now. 50 and 100. I'm not sure if it is. Okay, yeah, so we can see the number at the bottom. That is my car angle. Oh, and you can see it starting to move. It's just, I think, too small. Let's make our car speed 30. Yeah. I wonder why is it not always moving? Okay, I'm gonna, no, we do actually have 5 minutes, so I can keep trying to figure out. I might be doing something silly with X car, Y car. I think it's because I'm changing X car. Am I? No. Right now it's just moving in a circle, but I want it to always be moving forwards, and it's not. If I just make this like 45. I'm trying to find, because what's weird about this is that it should be moving automatically, but it is not. And the reason for that, I am not 100% sure. Oh, because I'm making it equal. It needs to be plus equals. There we go. Simple thing. Now, okay, now you see it goes off the screen. See, little things like that. Okay, now you can see it is going, but it's going way too quick off the screen. So even a whine. And so you can see I should be able to try and control its motion using that, but I need to be able to rotate the car according to that angle now. So I need to introduce whatever this is happening. So this push and pop, and then to rotate by that angle and translate to there. So it actually gets a little bit complicated. But if you follow along with that if you follow along with this code, that is what is making this move in the way that it is. I'm sorry I couldn't give a better answer. I think this will be like a full lesson to really explain why it's happening the way it is.
Got it. No problem. Thank you.
Awesome. Guys, before you jump off, please fill out this feedback form. This is as well going to be what is used to give out participation certificates. So we're only giving out participation certificates if you fill out the feedback form. So let me send that over here. And this will be how we get that. So the link that I just sent in the chat, please go ahead and fill that out. We'll send that link again later today, but go ahead and fill out that form. Other than that, guys, we'll be on the Discord to help answer questions and things like that. But we will see final projects coming in by next week, Sunday. And so looking forward to those. We'll be doing the prize giving the following week. I'll say goodbye. Bye, everybody. Make sure to fill out the form. And looking forward to seeing your awesome submissions.